have the natural log of x plus 1. So if we want to find the domain, we need to take another look at this, okay? If I rewrote this with parentheses, the only way that this is an equivalent statement is if I have the natural log of x plus 1. These two are the same exact thing. By putting a parentheses around the 1, it becomes similar to this function over here. But notice these are not the same thing, okay? Now this makes a difference because once we identify that we're only taking the natural log of x, not with the 1, then when we do the domain, it's always what's inside that parenthesis. So it's just x, and we know it has to be greater than 0. So the domain here is 0 to infinity, okay? Now to graph this, we always want to go back to our points. So again, I highly recommend getting in the habit of kind of writing this information out. So if we come down here to the points, we know we're going to have 1, 0. We're going to have the base 1. Now in this situation, natural log, what's the base of natural log? E. All right, so the base here is E1, and then 1 over E, negative 1, and then again we have x equals 0 for the asymptote. And then what are we doing to this problem? What are we doing to the natural log of x here? How is it changing? Up, down, left, right, reflect, stretch, shrink, what? We have our parent function plus 1. This is on the outside of our function, so that means it's a shift up 1. So you do need to know that. And if we're shifting up 1, are we changing x or y? Y. And what are we doing to every y? We're adding 1 to every single y. So we're going to have 1, 1, E2, 1 over E0, and x. This is x, but we're only changing y, so x equals 0 stays. So these are going to be the points. Okay, so our asymptote is still on x equals 0. We can draw that. We have the point 1, 1. E, what is E approximately? 2.7, good. So I'm going to draw 3, and I have 2.72. Now again, if you have this block of points in the asymptote, you do not need to add to the graph. If you are not taking these points and doing it this way, and you're just doing it in your head because there's only one step, then just label the points next to the graph, okay? So I have no preference. It is nice when it's this way because it is easier to grade, but I can grade it equally as well if you draw it on the graph. All right, so we have 2.72, and then 1 over E. What was that one? About 0.4, good. So 0.40, and then you can just draw your curve. All right, so now we can check. If we look here, we can see we're going from the asymptote to infinity, so 0 to infinity, and that matches what we calculated for our domain. What is the range always going to be for log functions? Range is always going to be, yeah, all real numbers, good. All right, how about the asymptote here? We already drew it, but what is it? X equals 0. All right, now we need to find the inverse. All right, tell me, what do we do first if we want to find the inverse? For every and all functions, the first step in finding the inverse algebraically is to change x and y. All right, so here we have y equals, now we're going to have x equals the natural log of y plus 1. Okay, now this one's a little trickier because right now we actually can't change forms, and the reason why is because the log is not by itself. Okay, so before you change to exponential, you have to have log isolated on one side, just the same as if we had exponential. You would have to have an exponential all by itself and all other terms on the other side. So notice we have two terms here. What we need to do is subtract 1 first. And now we can change forms. So the two questions, what are the two questions that we ask when we're changing forms? What's the base. And then the other one is what's the exponent. So your two questions, what's the base, what's the exponent? For this one, what's the base? Natural log. E, good, yeah, excellent. So the base is E. Now logs equal exponent, so what's the exponent here? Good. X minus 1, and the only other number left over? Which is great because then this is actually just going to be our answer because this is our inverse function. So this is e to the x minus 1. What's the convenience of finding the domain and range here? We already have it. We just have to flip-flop it. So since this is the domain of the log, then we know this is going to be the range of the exponential inverse function. And then the domain is all real numbers.